Okay, so now I need one for the activity. So select distinct, and so it's going to be the activity and the activity fee. Into, let's just call this activity from student activity payment. All right, let's run this one. Okay, so now I'm going to need an intersection table because a student could have multiple activities and an activity can have multiple students. So here we go. So I say select distinct, and I'm going to need a column from 1 to be able to tell them apart. Remember the referential integrity, so I'm going to need the student ID and the activity. Plus, I also now, there's a special type of intersection called an association table, where you actually throw in some extra data, for in this case, particularly the amount paid. Whoa. Into, I'm just going to call this student activity, or what do we call it? Payment. From student activity payment. All right. Whoa, I didn't get all of it. Oh, come on, machine. That's not fair. Okay, good. Execute. Boom. All right, let's go see what we got. So I'm going to go here and do refresh. So I should have an activity payment, right? I mean, an activity table. It's got 3 activities. Cool. I should have a student one, and just has the students. And then I should have a payment one, which has the combination of things. So student 100 golf, an amount he has paid. Okay, so apparently student 100 is skimming a little bit. He's behind. Student number 200 is as well. Okay, so it kind of sort of makes sense. Now let's put this all back together again, because remember, putting it all back together is kind of sort of important. So again, I'm going to start with the asterisk, and then maybe we'll come back and fix that. So I'm going to say select asterisk from, so I want activity. Okay. And then I'm going to say join student. You know, maybe I should have done the student first. Man, not that it really matters. Student join activity on. So do I have a way of connecting the two together? Is there a way to connect student with activity? Not directly. I'm going to have to go through that association table. So I have to do payment. Join payment on student.student ID is equal to payment.student ID. By the way, I'm definitely going to have to do Shift Control R here. Because, all right. So let me just run this to see what we got. So I got the student and the activity and the amount paid, but I don't have what the actual activity costs are. So I have to do another join. All right. Hey, I'm going to go ahead and break this up into chunks, just make it a little easier to see. Okay. So I'm just going to keep going, and I'm going to say join on activity. So why do I need the activity? Because I need to get what the activity cost is. So here it's going to be the payment activity is equal to activity. Boy, that activity fee. I probably should come up with better names. Okay, so now I've done a join, and now I got, whoa! Convert a cast of money. What the heck? Oh, not activity fee. Good grief. My apologies. I just wanted activity is equal to activity. The asterisk will take care of the fee part. So now I get my activity fee part. Ta-da! So the fee is $200, but he hadn't paid that much. Okay, so you see how this join works? So one more time. Why did I do it in the particular order? I did student first just for no particular reason. But student has no direct connection to the payment table. Okay? Because the payment table, I'm sorry, man, student has no direct connection to the activity table. The activity table doesn't have student IDs in it. Okay? So I have to go through payment. That's the intersection guy. So I had to go from student to the intersection, and then from the intersection back to the other table. So, if you were kind of looking at this graphically, I have these two guys at the top, and then an intersection in the middle. So I can't go directly across. I have to go pop down to the intersection and pop back up to the other guy. Okay, so that's Chapter 2, reinforcement. Nod your head. Yeah, okay, you're getting it. Woo, boy. So let me ask you a question. I see a lot of duplicates here. I see duplicates in the student ID. I have duplicates in the activity, and that's kind of annoying. So am I violating first normal form in this? Well, first of all, I have duplicate columns. So is this even a relation? What was one of the rules for a relation? That you can't have any duplicate rows or duplicate columns. So this doesn't even meet the definition of a relation, much less any normal form. Is that a problem? No, it's not a problem. This is what's called a result set. The output of a query is a result set. It doesn't have to follow any of the rules. The rules are for tables. This isn't real. This is just the output of a report, so to speak. Not stored in the database at all. Okay? Good. All right. Let's continue on with a different topic. Talk on page 206. So they start talking about common design problems that show up. So, multi-volume and multi-column problems. Yeah, when you run across a database, you can spot those. For example, if I have phone 1, phone 2, phone 3, phone 4, that's a multi-column problem. Okay. Inconsistent values. I tell this story about one time 10 million years ago. I was working at Fort Hood, and we were converting from one system to another. And the soldiers would come in and type in their addresses, and we were copying it from one database to another database. And I was astonished at how many people can't spell the word Copperas Cove, a local city in our area. So I had to go through and find all those broken spellings and manually fix them. It was terribly inconsistent. It was a pain. And then, maybe they filled in the zip code and maybe they didn't. And so once again, I had to go through and say, well, okay, that's this city, so most likely the zip code is this. I mean, sometimes you can figure it out from the city. Not always, but sometimes. And then, so inconsistent values and missing values, that requires human intervention, right? I mean, yeah, I could write some queries, that might find the misspellings of Copperas Cove, but I certainly would not ever have it automatically update based upon that. I mean, I would bring it up so I could see them, and I would manually go in. I mean, it wasn't difficult. I had it in my paste buffer. I'd go to the city and go paste, 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 paste. And if there was one that I went, I don't know what the heck that is, I'm not going to mess with it. But if I could tell for sure they were talking about Copperas Cove, well, then I would fix it. Okay. So those are the things. So, hey, what about address 1 and address 2? Is that considered like a multi-column problem? Well, not really, because some people have, 123 Any Street, apartment 4, and other people just have 123 Any Street. So that's not really, I don't really consider that a multi-column problem, because a multi-column problem works like this. I have a phone number and I need to figure out who that phone number belongs to. Well, I'll never have a query that says, I have an apartment number and I want to know who that apartment number belongs to. See? So that's not really a multi-column problem. Okay. Missing values. I mean, people just leave stuff blank. I mean, if you don't know what your zip code is, you can't remember, you leave it blank. Okay, that means some human has to come back and fix it. And the last one is what's called a general purpose remarks column. So it's considered bad form to just have a database design where you just say, what the heck, put whatever the heck you want in here. Because later on, you may decide to use that for something. Like, for example, I don't know, maybe you're doing a ticketing system because you're doing some sort of a tech support role. And so the ticketing system comes in and there's a remarks column and you start putting in, priority 1. and Party 2, that kind of thing. You start using it for something. Well, the problem is there's not going to be any rules for that column. I mean, you could type 1, or you could type WON, or you could type, you could type ONE, you can type, priority 1 with a space, without a space. I mean, there's no rules. So querying against general purpose remarks columns is practically useless. But the only thing you could do is you could sort on it maybe and go look, but ugh. So it's a sign of a bad design. So let's talk about multi-column one more time. Okay, so I'm going to pretend like I've got a database. So I'm going to type, select. So somebody told me that somebody's phone number. So select asterisk from employee where phone 1 is equal to 555 1234. Or phone 2 might be that, or phone 3, or phone 4. And so you can see how this thing just gets bigger and bigger and bigger and bigger. And it's a royal pain in the butt to do queries like this. If, on the other hand, you had solved the multi-column problem, well then there's probably going to be a thing called an employee phone table, where I just say the phone is equal to that, and it'll get them all. And so that is one reason, is because it makes the querying easier. But quite frankly, that's not the only reason. The other reason is I'm going to have to determine at design time how many phones you need. So I don't know, in the old days, before we had a bunch of cell phones, right? People would have like a home phone and an office phone. And so maybe your design had a spot for 2 phones, and that's it. And so someone comes in and goes, we need at least 4. We need your personal cell, and maybe you have a landline, and you have a landline at your desk. Maybe the company provides you, a work cell phone, so maybe we need 4. Well, if you did it the correct way to begin with, you could add as many phones as you want. 20 phones on there, fine, go right ahead. It doesn't matter. You don't have to change the design at all. So solving the multi-column problem at design time means that you have this infinite amount of flexibility for however many phones you want. I mean, another example is, I don't know, you're filling out a health form and they ask for a list of children. So I just decide how many children you're going to have? I think 12 ought to be enough. Anyone has more than 12 would be in bad shape. So I'm just going to have child 1, child 2, child 3, right? Oh, come on. That's just dumb, right? I can't do that. I'm going to have it so you can put in as many children as you want. Okay, good. All right. So we talked about this multi-column thing, but let me just pop on out and take a peek at the stuff in supplemental material. So here's an example. Here's a simple example where I have an employee and a bunch of phones, and I just come in here and instead of going horizontal, I just go vertical. I just change the design. So employee 12 phone, employee 12 phone, employee 12 phone. And this phone order is not necessarily important, but I'm assuming, for example, that the order of these phones, like phone 1 meant something. This could be home phone, cell phone, work cell. And then in that case, instead of being numbers, this would be some sort of like phone type or something. This one's pretty easy, but when you have an employee table with lots of stuff, this phone, if I try to do it this way, well then I have a second normal form violation, because the first name and last name don't rely on both parts of the primary key, only the first part. So you would have to go in and do 2 of these guys, an employee table by itself, and then in a phone table like before. Okay, kind of sort of makes sense. Okay, this is supposed to be a review from Chapter 3, so I hope you guys are following along. So multi-column is an interesting issue. It is not a normal form issue. Remember that. Okay, good. This is a good place to stop for the 15-minute mark.